we need to briefly discuss the topic of denormalization. Denormalization comes in two forms. First of all, it's the reverse of normalization. It's the undoing of normal forms. So you'd actually take, for instance, these tables and stick them back together again. Why would you do this? Typically you do this kind of thing in data warehouses, or you do it when your relational structure is so granular and subdivided up, typically down to third, fourth, and fifth normal form, that performance of SQL code joins against these multitude of tables performs so badly that you actually have to stick the data back together again. The point is this: the processing speed of SQL statements is much more important in relation to use of I/O space. In other words, use of I/O processing time. It's much easier to read the disk than it is to write well-performing complex SQL code joins. Also, disk space is cheap in the modern day, much cheaper than extremely powerful machines with lots and lots of processors and lots of powerful memory on them. One of the most significant factors with data modeling is future performance of applications against those data models. And the most significant factor on performance is SQL code, and particularly the need to build SQL code joins. A SQL code join is when you execute a SQL code statement such as a query to join multiple tables. It's much more efficient to read a single table than it is to join these three tables and read the data together. Also, you've got to consider the fact that when you're updating this data, if you want to update a single item down here and you only have the customer ID, you actually have to read through this whole structure. If it's all in a single table, it is likely to be a lot faster in terms of joining tables together. Obviously, when you stick all this data together, you're going to duplicate the customer name in the invoice and duplicate all these items in the invoice. You get problems with restrictions on the number of items you can place in each invoice, but you don't need to be concerned too much in the modern day with the price of disk I/O and the speed of I/O as much as you used to be. The more significant factor for performance is SQL code and minimizing the number of tables in joins. A poorly performing database can be a problem and can actually kill an application completely and even kill a company.